So, friends, welcome. So, today we will discuss about the process of landform development. So, in the last class we are talking something about the processes, what are their involvement in the landform development, and here one is process, another is landform development. That means, what type of processes are involved in the formation of a landform. And it is important to understand here is that whether one process is involved to form one landform or several processes are involved for one landform. So, this is important to understand here. So, what are these processes? For erosional landforms, the agents of erosion is climate, geographic positions, and the two parameters required to study. One is climate. Climate is the main culprit to form the landforms. For example, in arid climate, different landforms are formed which are characteristics of arid climate only. Similarly, in the cold climate, the glacial landforms are formed. So, they are characteristics of glacial landforms only. Similarly, some of these landforms they are characteristics of aeolian system. Some landforms they are characteristics of fluvial landforms. So, now if we can identify those characteristics landforms, we can talk about the geological past, what type of processes are involved in their formation. Therefore, the rate of landscape development and evolution is not same throughout. That means, sometimes some geological past the processes working at a higher rate and it may not be same throughout its history. So, for example, suppose we are taking a million of year time scale. Within that million year time scale, suppose one process is same process is continuing, but the rate of working, the rate of change in these processes is not same throughout. So, that involves the formation of landscape development. So, that means to form one landform, suppose for example, suppose forming a relict mountain, processes involved is the erosional landforms, erosional processes. That erosional process may be due to weathering and erosion by river, may be weathering of erosion by glaciers, may be weathering and erosion by landslides. So, that means weathering and erosion process, it can be divided or it can be done by three different agents or more. So, that means mountain system is one, the product is one in front of us, the product is simply a mountain front, but to form that mountain there are different processes are involved. So, that means these are these keys to understand whether one process is involved to design a landform or more than one processes are involved to design a landforms. So, if different processes are involved, whether it has been recorded within the land system, recorded within the rock body, that has to be unraveled. For example, if you see here this figure, we have a landform, mostly it is a fluvial landform. In fluvial landforms, there are three figures are here. One is called the youth stage. Youth stage means where the river originates, slope is very high, erosional capacity is more. So, that means those landforms will form, it is characteristics of those features. What are these products? V shaped valley, then no floodplain, extensive interfluves, many falls and rapids. So, that means you see those geomorphic landforms, they are characteristics of the youth stage. Similarly, if you are coming to mature stage, you are getting the landforms well dealt terrains, very less slopes, floodplains. So, if you are getting those type of landforms, that means the process which are characteristics in mature stage of a fluvial system, they are responsible. Similarly, you are coming to the old stage, those processes which are in characteristics of old stage, they are involved for formation of these landforms in the old stage. So, that means I want to say some of these characteristics processes, they are concentrated, they are restricted to a particular geographic position at particular geological times. So, those processes has to be unraveled and they have to be correlated. So, here within the processes that we have discussed earlier, there are two types of forces, one is destructive force, another is constructive force. So, now various processes acting in modifying the landscapes comes under the umbrella of functional geomorphology. Functional geomorphology, that means the product is a function of some process. Product in front of us, it is the landforms, these are the products. So, functions the processes. So, those processes either single handedly or in combination, they will modify the system and finally gives us the product. So, we are looking at the products only. By looking the products, by looking those involvement of the processes within the rock body, we are going back and unraveling geomorphological history and geological history. So, if you see here these processes, some of the processes are surfacial processes and some of the processes they are not surfacial, they are concealed in between. So, those who are acting on the surface, they are called exogenic process. Exogenic process, that means surface of the earth. Erosion, it is a surface of earth process. Fluvial erosion, it is a surface of earth process. Landslide, it is a process on the surface of the earth process. So, these are the exogenic processes, and some of the processes they are called endogenic processes. Endogenic process, they are not exposed to the surface. So, that means they are acting, but their activity is confined within the earth surface, but their activity influencing the superficial process. That means a product or a landform is a function of both exogenic and endogenic processes. So, exogenic processes, that means we are looking on the surface. Yes, a river is cutting its valley, but endogenic process we feel it, we evaluate it, but we cannot see it. So, many landforms have long history and their present form does not always related to the current process. That means, for example, suppose we have mountain fronts. For example, we take the example of Eastern Ghats. We have relict mountains. So, that means this mountain formation, the process involved nowadays may not be the same process involved in geological past. So, that is why this product is a function of many processes of endogenic and exogenic origin. So, if you take this lifespan, suppose for example, we are taking a lifespan of process of 10 years. 10 years of process involvement, we are getting pools and ripples, small sharks, ripples, beach cops, they are small events, small geological features. Similarly, if we are increasing the time span, suppose getting tens of million years, major drainage basins, large scale sand seas, continental coastlines, these are the products. So, that means for involvement of endogenic and exogenic process, the product is same, but the superficial processes sometimes dominant, sometimes the endogenic processes dominate. For example, suppose there is a plate movement, there is a volcanic eruption, but before eruption there is a magma pool beneath the earth surface. That means it is supplying higher heat flow. Higher heat flow if it is supplying, so that means it is affecting the superficial process. It is promoting erosion, it is promoting evaporation. So, rivers will evaporate its water and become dry. These are the endogenic process. So, that means some processes that are not exposed to the surface, but affecting the superficial process. These are the endogenic process. The nature and the rate of geomorphic process change with time, and some landforms are produced under different environmental conditions surviving today as a relict feature that we are talking about. A relict feature. Relict feature means the product is evidenced many geomorphic processes that acting in the past. So, that means whatever the process nowadays is acting may not be same process was acting in the geological past. Many processes acted together and finally they giving the product to us. This is the relict features. Eastern Ghat mountain fronts, they are the relict features. If you go to the river mouths, these estuaries, they are the relict features, because they were produced during the early phase of the quaternaries, where the sea level changes, eustatic sea level changes was there. They are the relict features. In high latitudes, many landforms are relict. They are for relict of quaternary glaciations. If you see in the quaternary, there was high level glaciations, worldwide there was glaciations, and glaciations means glacial features were involved, both the erosional features and the depositional features. So, if you go to the higher latitudes, so they are the relict feature. So, that means nowadays there is no glacier, it is dominant by fluvial environment, but though the fluvial system is acting 24/7 to modify its system, modify the geomorphology, but the last glacial effect it is there. That means those landforms were formed in the early quaternary, nowadays they are existing, and it is promoting this fluvial system to act, fluvial system to modify them, but still they are existing, the landforms are existing, they are the relict landforms. So, that means some of these landforms, this, if you are talking about the quaternary, that means we are talking about this 2.6 million years back, but some of the landforms they are surviving from billion years old, they are also the relict landforms. So, that means the relict landforms which are existing today, that means they are evidence that the process is not acting at higher rate, so that it can penetrate them. Even if the process was acting, the landforms they are remain as intact. So, that means some of these processes they are acting at a higher rate to modify the system, some of the processes they are acting at a very slower rate, so that it is taking long time or even if millions of scale to modify the system. So, that is why these relict landforms are existing. Historical dimension of geomorphology comes under the domain of historical geomorphology. Historical geomorphology, it is very important to understand. Historical geomorphology means geomorphological history. That means place remains same, but different geomorphological process they are acting in geological past. So, geographic position remains same. For example, if you take this image here, the photographs here, we have different layers, rock layers. One layer here, another layer here, another layer here, another layer here. Similarly, here if you see layer 1, 2, 3 and finally, we are getting an erosional surface and then again. So, that means I want to say geographical position is same, but the geomorphic processes are different in geological times. So, if we can correlate, if we can arrange those geomorphological processes from bottom to top, that means we are unraveling the geomorphological history, that is the historical geomorphology, is not it. So, if you see here, for example, this photograph is from the Himalayas. Now, you see we have conglomerates, fluvial conglomerates, then we have sandstones, then again we have conglomerate, then we have an erosional surface, then we have conglomerate, then sandstone and soil. So, now you see this conglomerate, sandstone, conglomerate, it is this total system from this to this, it is by fluvial origin, it is a fluvial process was acting there. But if you see here, this is an erosional surface. If erosional surface, that means this area was beyond deposition or the above the depositional level. So, now the question arises, if fluvial process was involved formation of this system from here to here, so at this geological time where the fluvial processes were there, because this area was beyond or above the depositional level. So, now the two cases arises, either the area was beyond or above the depositional level, or this fluvial system or the depositional system was not existing there. So, if the first is true, we know the Himalayan system, it is mostly the tectonically active region. In tectonically active region, if we uplift something above this river depositional level, so same thing can happen. Or if we remove this depositional system from this place, so that means in a tectonically active region, we do not have any river system, that means river was diverted, or there is a climatic change, the river was dried up. So, that means there are many possibilities are there. So, a geomorphologist, the main work is to unravel the most possible geomorphological history, what was the reason behind it. So, that is why geomorphological history unraveling, we need rock exposures. Until unless we have exposures, we are helpless. So, where to study? So, studying a geomorphological history of a region, we need proper exposure and proper preservation of rock record. For example, suppose we do not have rock record, there was a disaster environment, there was a disaster, geological disaster, there was a flood, high flash flood, but subsequent events they wiped out its evidences. We cannot study, even if there were processes involved, but the process do not have any rock record. So, that means to unraveling the geomorphological history of a region, we must have rock record in front of us. For historical geomorphology, the golden rule is present is key to the past. What does it mean? So, that means we have rock record, some processes we have to identify. Now, how to correlate whether this particular process is involved there? That means we have to see the present. The modern environment, modern geomorphological environments, what type of process give rise what type of product? We have to correlate with the past. So, that means in front of us what are the processes are going on and what are their products. If you can precisely correlate, then the same system we are taking here and putting in the rock record. Then we can say yes, these are the process and this is the product. Similarly, these products are available. So, that means we can correlate the process. So, present is key to the past. This was in warrant to assume that effect of geomorphic process seen acting today may be legitimately used in for the causes of assumed landscape changes in the past. To unravel the historical geomorphic process, we need exposed geological section with date constant, that is important. We should have exposed geomorphological sections, geological sections, and we should have date constants, we should have time. Without time, everything is gone. So, that means once we are saying it is a geomorphological process was involved, now the question arises when it was working. So, what duration it is working and when it was acting, that is also important. So, if you can answer those two questions, one is process was involved, this is the product, and this process was started from this years ago or this million years ago, it continued up to this million years ago. So, to the rate of working of that process that can be unraveled. So, that means we have process, we have rate of working and we have product. If the three things can be correlated, then it is complete solution to a geomorphological problem. Otherwise, we do not have. So, for example, here this figure, if you see in figure A, if you see this is limestone, it is exposed to hundreds of, suppose say thousands of years. We know limestones, they are very prone to chemical weathering. So, after thousands of years of or hundreds of years of exposure, we are creating a surface, erosional surface here. Mostly it is called calcareous crust. Now, you see if this is so, now we are creating a valley is created, and the valley, that means valley is created means fluvial system will develop. So, once the fluvial system is developed, this valley is filled with fluvial sediment. Now, you see this fluvial sediment, once it is developed, due to some reason this fluvial system changed its course. So, now you see this fluvial system, within this system there is a river which is passing through, and this is the river bed, and this is the flood plains. So, now the river is cross cutting its own flood plain. So, we will have river bed sediment, we will have the flood plain sediments. Now, if you see here again the river with time it widens its valley. So, the present day river course, the sediment is involved here. So, we have bedrock, we have past depositional system, the product is this, we have the present depositional system, the product is this. So, now if you see here in this figure, we have a complete rock record of this bedrock, then the older fields, then the younger fields, and if you see concentrate here, this is the modern day river sediments. So, we are taking the cross section, that means we are getting the complete rock record, and through the rock record we are correlating this process and products and the time duration, when and what time duration it was acting. So, that means in this valley, if you want to unravel the geomorphological history, it is only and only possible if the exposure is there. For example, if you see here, these two are the ground penetrating radar profile. In ground penetrating radar profile, if you see here the red marked, it is a paleo channel, surfacial sediments they are burying it. If we do not have this geophysical profile or this radar profile, we cannot say whether in the past a fluvial system was active here, is not it. So, that means some cases. Similarly, here this is a paleo channel buried under sediment. Nowadays, there is no channel existing there, it is completely a peneplained area, soil development is there. So, it is buried under soil. Soil development means the area is exposed and area is undergoing active erosion. So, that is why soil formation is going on there. So, that means present day geomorphology, it is simply it is beyond the depositional level or above the depositional level and is exposed to the surface, soil formation is going on. But if you see this radar profile and if we date it, for example, suppose we date it at 10,000, for example, it is 10,000 years back. So, that means if we remove the superficial sediments, we are removing 10,000 years from the geological time, then we see at this particular geographic region a river was existing, a channel was active channel was existing, active deposition was going on, and with time the river was dried up, it is filled with sediment, it is promoted soil formation, and now there is no signature of a river profile was existing. So, that means at certain cases we have these geophysical tools, they are helpful in unraveling the geomorphological history, but at many cases it is not possible. So, that is why rock record is the best medium to study the geomorphological history. Now, the rock structure beneath the earth that influence the geomorphology. So, there are two types of structures, one is called active structures, another is called inactive structures. Inactive structures means that means the structure was formed in the geological past, it is not reactivated. So, whatever the activity was there, it is in the geological past. Suppose we are considered to unravel the geomorphological history of a quaternary, but the rock structure beyond that, beneath that are active beyond the quaternary. Within that quaternary or within the time scale we are taking to study the geomorphological history, within that time scale it is not active. So, these are called inactive structures. For example, if you see this figure, suppose it is a fold. So, that means if you consider the initial time of this fold, we have a valley, and a hill was existing here. Similarly, we have valley here, a hill was existing here. Similarly, we have a valley here. So, that means valley, hill adjacent to each other. But nowadays, if you see here, we have a valley existing at the top of this mountain. So, these are called the anticlinal hills and synclinal ridges. So, if you remember the last class, we are talking about the relict features, and the relict features, they say about the degree of maturity of the topography. So, this is called mature topography. Mature topography means, here if you see, we have an anticline, and due to anticline, this part is under pressure. The rocks are extended, stretched. So, once we are stretching the system, that means we are creating some fractures parallel to this, we are stretching some fractures. So, due to these fractures, this zone becomes a weak zone, and the rocks are removed from here. So, that means we have a valley here, now we are creating a valley here. So, many of these relict features, they show the anticlinal valley and synclinal ridge. If you go to these Precambrians of the Himalayas, you go to the Precambrians of this peninsular India, you will find many such type of relict structures. Okay. So, that means they are in the subsurface, but they are acting the superficial processes. Similarly, some of the structures, they are exposed to the surface. For example, here you see, this is exposed to the surface, the valley it is exposed, the hill it is exposed. Here this is volcano, this is exposed to the surface, the folds that is exposed to the surface. And if you see the geomorphological process, for example, here concentrate here in this particular figure, it is the volcano here, and if you the volcano is here, can see the rivers, the channels, they are radiating in all directions. They are creating a radial drainage system. That means it is affecting the geomorphology, affecting the geomorphological process, it is affecting the fluvial processes, is not it? Similarly, if you consider these are the subsurface structures. For example, suppose we have horizontal strata, we are creating a dendritic drainage on that. We have a inclined strata, gentle dipping strata, we are creating mostly parallel drainage. Similarly, if we have anticline, syncline, we are getting the parallel drainage system, the trellis drainage system, and rectangular drainage system, you are getting the fractured rocks. So, that means I want to say subsurface structure, subsurface rock arrangement, it affect the superficial geomorphic process to certain extent. This we are talking about the inactive structure, that means once it was the structure was formed and later on it was not activated, this is affecting. So, this is called the time taken to respond a geomorphic system to a particular event. For example, suppose we have a fault, and on this fault, across this fault, we are creating a drainage system. So, across this fault, if you are creating a drainage system, with time the fault scarp will be eroded. At present, we have two topographical difference, one is upthrown block, another is the downthrown block. A river which is coming from the upthrown block, it will erode the fault scarp and finally deposit in the system, is not it? So, now the question arises, to what extent, to what time frame or to what time scale the fault scarp will exist, that depends upon the climate, they are depending upon the rock type, they are depending upon the surfacial processes involved to penetrate them. So, suppose the rate of erosion is more, or the rocks involved in the fault, it is very fragile rocks. So, that means the fault scarp will erode very easily, and finally, within a few hundreds of years, few thousands of years, these two sides of the fault, the upthrown and downthrown block, they will be peneplaned. Like the Ganga plain, it is mostly alluvium. if you are creating a fault on the surface and it is creating topographic difference, it will take hundreds of years to peneplane the system, because the Ganga plain, the sediment is very friable, it is unconsolidated sediment, the fluvial system is very active, is not it. So, that is why this upthrown block will erode very fast and will deposit sediment on the downthrown block. So, now the time taken to respond the geomorphic process to that faulting event is very less, hundreds of years, thousands of years. But if the same throw of a fault occurs in peninsular India, it is mostly hard rock, peninsular gneissic complex, hard rock, sediment supply is less, fluvial system is very sparsely disseminated. So, that means even if after millions of years this fault scarp will remain as it is or very slight modification. So, that means I want to say the fluvial or the system responds to a particular event, the geomorphic system responds to a particular event. The time taken for respond varies from place to place, varies from time to time. For example, the same time, same process, same fault scarp, it is in the arid region, the same fault scarp, it is in the humid region. The degree, the time taken to peneplane varies from place to place, varies from climate to climate, varies from time to time. So, that means this inactive structure means those structures which was formed at geological past, and if it is present day it is existing. So, that means I want to say the geomorphic system responds to that particular structure very little and very slow. But if it is there in otherwise, if the geomorphic system acting very fast, so that means that fault scarp with very small time it will peneplane. And another type of structure, it is called active structure. Active structure means the structure was either it is present in the past and it is continuing its existence, it is continuing its activity today, or a new active structure is present or creating today simultaneously with the geomorphic process. That means this rock structure which is creating today and the geomorphic system is also acting today. But in inactive structures, the rock structure was present in the past, but the geomorphic processes that is acting today. So, this is the difference between. For example, if you see here, we have active structures. For example, if you see this figure, this is a fault in the basement level. In the basement level, if we are creating a fault, these are the sediments, cover sediments. So, that means in A, if you see this figure A, we are creating a fault in the basement level. In the B, the sediment close to this basement it is affected. So, now if it is close to basement is affected, in figure C, gradually if you see this overlying sediment is affected, and finally small scale faults are forming on the surface. And here in the figure D, if you see, there are number of small scale faults creating a fault zone on the surface. So, in this subsurface we have only one fault, it is in a hard rock, it is in basement, but in the surface we are creating number of faults, we are creating a fault zone. So, that means a geomorphic processes we are creating on the surface of a wide area, and here at the same time this fault is active and the geomorphic process is also active at the present day geomorphic system. These are called active structures. That means rock structure which is present at the subsurface, it is presently active and its activity it is influencing the surfacial process. This is called active structure. Similarly, if you see here. Here a fluvial system, it was on working without effect of any structure. With time, if you see, we are creating a fault across the river course. So, with time the fault grows, the length of the fault grows, similarly the depth grows. So, with time, if a full fledged fault is created, now you see here the river was going on here smoothly, and here due to this activity of the fault, due to the activity of the growth of this fault, the fluvial system, some changes occur within the fluvial system. And finally, if you see here, some of the river which are going independently, now they are merged with each other. And finally, some of these paleochannels remained here. So, this is affecting the present day structure and this present day geomorphic system, and this structure is active nowadays. So, this is called active structures. So, active structures, they affect more to the present day geomorphic system as compared to the inactive structures. So, some other examples here, we have a fault here and surface, this fault is representing a fault zone. If it is fault zone is there, now you see this river which is coming or is moving smoothly within that fault zone, you see the sinuosity changes. The sinuosity changes. Similarly, here sinuosity changes. We have some erosional topography close to this fault. So, these are the active structures, it is affecting the surfacial process. Very interesting example is here for East Patna fault in the Ganga plain. East Patna fault, it is a subsurface fault which is covered with sediment, and this is the digital elevation model around it. Now, if you see this is the East Patna fault, and now if you can see the fault zone, how this topography is changing there. Now, this is the effect of this fault is there. Earlier the Son river was somewhere here. If you see the satellite imagery, you have seen that the Son river has changed its course. This is the effect of fault, this is the effect of active structure. So, that means a mighty river Son, it is changing its course due to this fault effect. So, that means the subsurface structure, the subsurface active structure, it is influencing the surfacial process, the fluvial process, the river process. Similarly, sometimes if you see here, sometimes these structures they mislead the geomorphologist, and one example is here from the Ganga plain. If you see here, as a layman, if you walk from here to here, what you will get? You are coming plane and finally you are coming higher tide. So, it is looking like normal fault, a topographic difference, normal fault, but this subsurface study by geophysical method, it is proved that this is not a normal fault. This is a reverse fault here, and due to this reverse fault, this area is uplifted, and this is the fault scarp erosion. This is the fault scarp retreat. Due to this retreat, you are find a topographical difference here, and it is looking like normal fault, but it is a reverse fault. So, some of these photographs if you see here, this is Mungir-Sirsar ridge fault, East Patna fault, West Patna fault. So, all those faults if you arrange and this geomorphology of the Ganga plain is correlated, then you will find these active structures, they are influencing the surfacial geomorphology. Either it is the erosional process, it is the depositional process, any type of process if you involve, these subsurface structures they influence. How we can say whether this is a active structure or inactive structure. Inactive structure I have already discussed that it was formed in the geological past and present day its activity is 0, but the geomorphic system is responding to that event which acted in geological past. Okay. But the active structure, if you see, we have fluvial geomorphology, an example fluvial geomorphology affect by fault mostly in the alluvial plains. Alluvial plains, it is totally penaplaned area, almost flat, lack of any topographic prominence. In that area, it is very difficult to identify whether an active structure is existing or not. In hilly terrains, we have exposures. If it is fault there, you go to a river valley, you will find this existence of this fault. But in plain area, which is concealed totally on the alluvial plains, it is difficult. That is why this fluvial geomorphology plays an important role to identify these active structures on the penaplaned area. Here some of these examples of how this fluvial geomorphology is used to study the active structures in a geomorphic system. One is your drainage convergence. If you see along these faults or across this fault, for example, if you see this fault, see 3 channels 1, 2, 3 they are converging here. Similarly, here there is a drainage convergence, here there is a drainage convergence, here there is a drainage convergence. So, not always the convergence drainage is always indicative of fault, no, not necessarily, but if there are fault existing, there are maximum chance there will be drainage convergence along this fault zone, but not necessarily wherever you will find a drainage convergence you will say yes it is a fault is existing here, no, not necessarily. So, that is why to find out a fault there are many geomorphic evidences are there. One of these there is the convergence drainage. Another is offsets. It is very prominent characteristics of active fault. For example, if you see here there is an offset of here, there is a offset of here. So, offsetting streams either it is normal fault or it is reverse fault or it is a strike slip fault, that 3 possibilities are there. Okay. New stream generation is another point. Why? Once we have a fault in the alluvial system, we have a topographic difference. So, once we have a topographic difference, that means we are creating some gullies, some later on gullies will converted to valleys and finally, the first order streams will develop. You see any of this fault if you see, we have new streams generated, we have new streams generated, we have new streams generated, generation of new streams everywhere you will get new stream generation. It is due to the topographic difference. So, that means I want to say these are some of these parameters, they are used to study these active structures on the surface. Then valley height to width ratio, this is a very important parameter, but this is not true in case of alluvial rivers, because alluvial rivers either it is upthrown or it is downthrown, it is filled by alluvium, very mobile elements. That means it can easily be modified during a flood. If you see this Ganga plain rivers or any alluvial plain rivers in the world, during a flood there will be river valley will highly migrate either this way or that way. So, it will completely modify this river valley system. So, that is why this parameter does not hold good for alluvium rivers. So, now another example is here, that in a global scale how these structures they affect geomorphology. For example, in a global example, if you take this basin and range province of USA, here you see number of ridges, number of valleys, this is due to extension, this is due to extension. So, that means we are creating host and gravens, number of hundreds of host and gravens are there. So, hundreds of host and gravens, that means ridge, valley, like this. So, we will get parallel drainage system. So, here if we are having half graben, here if we have half graben means one side it is bound by normal fault. So, now we see we have this side we are bounded by normal faults, and at the initial time a river was existing here and flowing in this way. Now, more and more sediment fill, more and more loading. Now, you see this system is bending downward. So, the fluvial system which was existing here, now it is migrating to this side. Similarly, here another example of surface structure, how it is affecting the surface. Here the basement fault zone in Indian east coast. And now, if you see the basement, it is fault zone, it is existing thousands meters below. That means 1 kilometer below a basement fault is existing, from 1 kilometer to 2.5 kilometer below. Now, if you see the surface structures, we are getting small scale faults, and if it can be well correlated. So, that means I want to say the subsurface structures, they act very precisely, very actively to influence the surfacial system. So, we can conclude here, though we have structures in the subsurface, they can active or inactive. If it is inactive, that means the fluvial system or any geomorphic system, they can act freely without any hindrance. But if we have a active structure, if we have an active structure here, that activity occurs in time to time that influence the fluvial system or any geomorphic system in the surface actively. So, this is the conclusion of the system. Thank you very much.